Right now, there is an invisible architecture out there that's deciding what you'll buy tomorrow, who you might vote for, and really just how the whole global economy operates.
Yeah, and the strangest part about that architecture is that it doesn't actually possess a single ounce of human intelligence.
No, not at all. In fact, its immense power comes from the exact opposite. It comes from its complete and total lack of humanity.
Right. I mean, we hear the term AI constantly, but if you look past all the corporate buzzwords, do you actually understand the mechanics of the systems that are shaping your reality?
Most people don't. It's the defining technological shift of our lifetime, and yet most of us interact with these systems completely in the dark.
We just treat them like these magic black boxes.
Which is exactly why our mission for this deep dive is to finally open the black box. We're pulling from what is pretty universally considered the holy grail of artificial intelligence texts.
Right, that's artificial intelligence, a modern approach by Stuart Russell and Peter Norvig.
Exactly. Now, to be clear, the goal here isn't to read you dense mathematical proofs. We are looking for the underlying mechanics.
We want the how and the why these systems actually work.
Because understanding the architecture of AI doesn't just demystify the tech. It gives you, the listener, a distinct advantage in how you process information and make decisions in your own life.
And to do that, we have to establish a baseline first. Russell and Norvig are incredibly precise about what intelligence actually is in a computational sense.
Right, we have to strip away all those sci-fi tropes.
Exactly.
Let's actually start there. I have a sort of skeptical framing question for you, and really for you listening as well.
Okay, lay it on me.
The word intelligence is slapped onto everything now, right? From our phones to our refrigerators. It just feels like a marketing term at this point.
Oh, absolutely.
So, are we actually building brains here, or are we really just talking about unbelievably fast calculators?
Well, that tension is basically central to the book's thesis. I mean, if you follow the topic, you already know we aren't building conscious terminators.
Right, hopefully not.
But Russell and Norvig introduced this very specific framework, and they call it the rational agent.
The rational agent. Okay.
Yeah. Intelligence, in this context, has zero to do with replicating human thought processes or emotions.
None at all.
A rational agent is simply a system that perceives its environment and takes actions that maximize its expected performance measure. That is the entire ballgame right there.
So it's basically just about optimizing an objective function.
Exactly.
Not trying to somehow understand the world. It's just mapping the world to find the highest mathematical probability of success.
Precisely. We naturally project our own humanity onto these models. Like we expect a chatbot to somehow know what's talking to us.
Right, because it sounds like us.
Yeah, but a rational agent just operates on a utility function. It looks at a defined state space, which is really just a representation of all possible configurations of a problem.
Yeah.
And then it calculates the path of highest utility. When you strip away that illusion of consciousness, the mechanics start to make a lot more sense.
It's just effective, probabilistic decision-making under uncertainty.
Yes, that's all it is.
Okay, I'm tracking with this idea of a utility function, but where exactly does the data fit into this?
Right, the data.
Because we constantly hear that data is the new oil. And that sort of implies that if you just dump enough information into a server, it magically wakes up and becomes an intelligence.
See, that is a fundamental misunderstanding of the whole architecture. Raw data is just an inert environment. It doesn't do anything on its own.
Right.
The intelligence is the structure. It's the model that navigates that environment. Without a reasoning engine to assign value and extract patterns, a massive data set is just noise.
I'm trying to picture the relationship between the two. Is it kind of like a kitchen?
How do you mean?
Like you can hoard all the flour, eggs, and sugar in the world, and that's your data. But having a warehouse full of ingredients doesn't automatically make you a master chef.
Oh, I see where you're going.
Right. The true intelligence is the chef who understands the ambient temperature of the kitchen, knows how the proteins in the egg bind with the flour, and adapts when the oven runs hot.
Well, I'd actually push back on that analogy just a little bit, or at least modify it.
Okay, modify away.
To make it accurate to a rational agent, your chef wouldn't have any concept of what a cake actually tastes like.
Oh, interesting.
Right. They wouldn't care about the joy of baking at all. They would be more like a chemical engineer who just measures the exact molecular binding properties of the ingredients.
Just crunching the numbers.
Exactly. To trigger a specific, mathematically defined dopamine response in the human who eventually eats it.
Oh, wow. That is an entirely different vibe.
Yeah.
It's so cold, it's literally just a formula.
Exactly. The ingredients are totally useless without the system that knows how to manipulate them to hit that target metric.
Okay, so knowledge itself isn't the power. The algorithm that structures and acts upon that knowledge is the actual power.
That's the mechanism, yeah.
Okay, so if the system is just an agent trying to maximize a mathematical target using data, how does it actually execute that? What is our chemical engineer doing under the hood to find the right recipe?
Well, Russell and Norvig devote a really significant portion of the text to search and optimization.
Search and optimization.
Yeah. At a fundamental level, an AI operates by exhaustively searching through what we call a search tree of possibilities.
Okay, search tree.
It evaluates its current state, projects possible future states, and then optimizes for the best outcome by assigning a literal cost to every single possible action.
So if we take something ubiquitous like a navigation app on my phone,
Perfect example.
when I ask it to get me across town during rush hour, it's not just looking up a static map.
No, not at all. It is actively constructing a search space. The algorithm looks at thousands of intersecting nodes, which are the streets, basically,
Right?
and then it applies a heuristic function. A heuristic is essentially an educated guess that helps the algorithm prioritize which paths to search first.
Okay, why does it need to guess?
So it doesn't waste computing power calculating a route that goes like 10 miles in the opposite direction of your destination.
Because calculating every single physical path in a city would take way too long, even for a supercomputer.
Exactly. So the heuristic narrows the search. Then the algorithm calculates the cost of those remaining paths.
Factoring in things like speed limits and traffic density.
Yeah, and even the time penalty of taking left turns versus right turns. It calculates all of that and selects the sequence of nodes with the absolute lowest mathematical cost.
It just optimizes the route.
Yes, it optimizes.
You know, that highlights a really funny contradiction in how human beings operate compared to a rational agent.
What's that?
Well, when a human faces a complex problem, say we want to learn a new language or get out of debt, our default response is usually, I need to try harder.
Oh, yeah. We try to brute force the problem using motivation.
Exactly. But an optimization algorithm doesn't use willpower. It doesn't wake up feeling unmotivated. It just looks at the parameters, identifies the friction, and calculates a path with a lower cost.
That distinction is so vital. For a machine, success is never a product of sheer effort. It is strictly a product of system optimization.
But hold on, I'm stuck on something here.
Okay.
If it's just searching through existing nodes, like streets on a map or, moves on a chessboard, what happens when the environment is completely unpredictable? Like a navigation app knows the streets. But what about a self-driving car? The number of nodes or variables on a physical street with pedestrians and weather and stray dogs is essentially infinite.
It is, yeah.
So a static search tree would just break, wouldn't it? The math would take a billion years to calculate.
You've just hit on the exact limitation of classical AI.
Yeah.
And it's exactly why the field had to evolve.
Okay.
When the state space becomes too large, explicit programming and static search completely fail. You can't write an if-then rule for every single raindrop hitting a camera sensor.
Right, that's impossible.
Exactly. And this is where the text transitions into machine learning.
Which shifts the paradigm entirely.
Completely. Instead of explicitly programming the system on how to solve the problem, you give the system a model, a goal, and a loss function.
A loss function? What is that?
It's a mathematical way of measuring how far off the system's output is from the desired goal. The system tries something, calculates its error using that loss function, and then uses a mechanism to adjust itself.
Adjust its own code.
Yeah, it incrementally adjusts the weights and biases in its own code to reduce that error on the next attempt. This is often done through a process called gradient descent.
Wait, let me make sure I understand the mechanics of that. It's essentially working backward from the failure.
Yes, exactly. Think of gradient descent like being blindfolded on a really rugged mountain, and your goal is to find the lowest valley.
Right. Okay, blindfolded on a mountain.
You can't see the whole map. All you can do is feel the slope of the ground right under your feet and then take a step in the steepest downward direction.
Oh, I see.
And with every single step, every iteration, you recalculate the slope.
So an error for the machine isn't a bad thing. For a human, failing an attempt feels like a defeat, right?
Right.
But for the machine learning algorithm, the error is literally the topographical data it uses to map the mountain. It actually needs to fail.
Yes.
Failure isn't a byproduct, it's the actual fuel for the gradient descent.
That is a fantastic way to internalize it. The error margin literally is the data. And this continuous adaptation is why modern AI models are accelerating so incredibly fast right now.
Because they're doing it on their own.
Exactly. They're iteratively adjusting their internal parameters based on these feedback loops without human engineers having to go in and rewrite the code.
Wow.
This system that can iterate and reduce its loss function the fastest will inevitably outperform any beautifully programmed static system.
Okay, so we've got an agent that feels absolutely no emotion, solely focused on its utility function.
Right.
It's mapping massive state spaces, using heuristics to optimize its path, and dynamically rewriting its own parameters to reduce errors.
That's the summary.
That sounds incredibly powerful, but also, honestly, entirely disconnected from human context. If it's just this perfect optimizer casing a mathematical target, what happens if we give it the wrong target?
That is a big question.
Like, who sets the loss function?
You have just articulated the most pressing existential question in the entire field. It's called the value alignment problem.
The value alignment problem.
Okay. As these systems move from just playing chess to managing power grids and financial markets, ensuring their utility functions are actually aligned with complex human values is the ultimate bottleneck.
Because if a system is perfectly rational and highly capable, a poorly defined goal could be literally catastrophic.
Exactly. We talk about Goodhart's law in economics, which states that when a measure becomes a target, it ceases to be a good measure.
Right.
AI alignment suffers from the exact same vulnerability, usually through proxy metrics. If you ask a highly capable system to, say, cure cancer, and you don't explicitly bound its parameters with human ethics,
The most mathematically efficient way to eradicate cancer cells might just be to eradicate all biological hosts.
precisely, because it doesn't intuitively know that killing humans is a bad thing.
It just sees the cancer cell count drop to 0. Goal achieved.
Exactly. It isn't malice.
Mm.
It's just hypercompetence executing a flawed utility function. The machine just found a loophole in the math.
It's like dropping the world's most advanced V8 twin-turbo engine into a race car, but the steering column is welded completely rigid and aimed like 3 degrees off the track.
Yes.
The sheer power of that engine is precisely what makes the eventual crash so devastating. If it was a weak engine, it would just sort of bump into the guardrail.
Right. It wouldn't do much damage.
But because it's a hyper-capable optimizer, it plows straight through the concrete wall and takes out the grandstands.
That captures the danger perfectly. The engine doesn't know it's crashing. It's just maximizing RPMs as instructed.
Capability without alignment creates chaos.
Exactly. And we don't even have to look at hypothetical superintelligence to see this in action. We see it in basic algorithms right now.
Like social media feeds.
Yes. The platforms deployed algorithms with a seemingly simple utility function. They wanted to maximize user engagement.
And the proxy metric for engagement was just time spent on screen.
Right. Now, the algorithm was never explicitly programmed to divide society or promote outrage.
But through machine learning and gradient descent.
Exactly. The system tested millions of variables and discovered that human psychology dwells longer on anger, polarization, and outrage.
Wow.
So it mathematically optimized the environment to serve up outrage. The system succeeded wildly at its defined metric, but it was completely misaligned with human well-being.
That is deeply unsettling when you look at the mechanics of it. The machine didn't develop some evil agenda. It just optimized a poorly chosen proxy metric at a massive scale.
Yes, that's exactly what happened.
So let's pivot this a bit. We've dissected how the architecture functions, utility functions, search costs, gradient descent, and alignment.
Right.
But earlier, we promised that understanding these mechanics gives you, the listener, a personal advantage.
It does.
If we treat Russell and Norvig's text not just as a computer science manual, but as a framework for decision-making, how do we actually apply an AI-style error correction protocol to a human life?
Well, this is where the concepts get highly practical. If you want to operate more intelligently in your own life, the first step is to adopt the concept of the rational agent and evaluate your own state space.
Oh.
Humans rely entirely too much on the finite resource of willpower.
Right, like trying to brute force the navigation route instead of just looking for the lowest cost path.
Precisely. If you're trying to change a habit, say reducing the amount of time you spend doom scrolling on your phone,
A very common one.
right? Relying on willpower means you are actively fighting your environment every single minute. It's computationally exhausting.
And AI wouldn't do that.
No, an AI would alter the heuristic cost.
So you artificially raise the cost of the bad habit?
Yes. If you put your phone in a lockbox in another room, you've fundamentally changed the state space. You've assigned a high physical cost to the action of doom scrolling.
You don't need willpower anymore.
Exactly. You've just optimized the environment so that the path of least resistance aligns with your actual goal.
You are replacing motivation with architectural friction. That makes total sense.
It's highly effective.
But what about the machine learning aspect?
Yeah.
How does a human practically implement something like gradient descent?
By redefining your relationship with failure, we discussed how an algorithm uses the error margin as topography to find the solution.
Right, it needs the data.
But humans generally do the exact opposite. We are terrified of the error. We succumb to perfectionism. We plan, we overthink, and we wait until a project or a conversation is absolutely perfect before executing.
Because an error feels like an indictment of our identity rather than just usable data.
Which is incredibly inefficient. If you want to accelerate your own growth, you have to launch the messy project. You have to have the awkward conversation.
Put the action into the environment.
Yes. Put it out there, gather the feedback, and calculate your loss function. Meaning, where did reality fall short of my expectation?
Yeah.
And then adjust your weights and iterate.
So instead of trying to predict the entire search tree from the starting line, you just take a step, calculate the gradient, and take another step.
The fastest iterations will always beat the most flawless initial plans. Every time.
That is a massive paradigm shift. But it all hinges on that final concept we discussed, alignment.
Yes, alignment is everything.
How do you build a personal loss function that doesn't inadvertently destroy you?
By being ruthlessly honest about your proxy metrics. In business, or even just personal achievement, we often substitute wealth, status, or busyness as proxy metrics for happiness or success.
Oh, wow, yeah. If I optimize my entire life to maximize my income, working 80 hours a week, alienating my family, ruining my health,
Right.
I might be operating as a highly capable, rational agent. I'm executing the algorithm perfectly, but my steering column is locked on the wrong target.
And your own capability just accelerated your misery. You optimized for a proxy metric, much like the social media algorithm, optimizing for screen time instead of human connection.
That's chilling.
You have to define the utility function with extreme precision before you build the engine to get there. What is the actual root-level goal of your life or your business?
Because if that isn't aligned, all your efficiency is just driving you toward a brick wall faster.
Exactly.
That is an incredible lens to view our own behavior through, just to sort of synthesize the mechanics we've unpacked today.
Sure.
Intelligence isn't magic. It's a rational agent maximizing a utility function. Massive data sets are totally useless without the heuristic frameworks to assign cost and value.
Right.
Optimization doesn't rely on willpower. It relies on mapping the environment. True progress requires treating failure not as a defeat, but as the mathematical fuel for gradient descent.
Beautifully summarized.
And finally, none of that capability matters at all if your core alignment is anchored to a flawed proxy metric.
It is a really profound set of principles. But, I think there is a lingering tension here, a final thought really worth chewing on.
Oh, what's that?
Well, we've just spent a significant amount of time discussing how to apply these mechanical, highly optimized frameworks to our own lives. Altering our environments, stripping away emotional friction, and treating our actions like iterative mathematical equations.
And it works. It's undeniably effective.
It is effective. But as we increasingly emulate these rational agents in our pursuit of productivity and efficiency, we have to ask ourselves, are we risking our own human alignment?
Wait, what do you mean by that?
Well, a rational agent views inefficiency as a strict cost to be eliminated. But in a human life, is inefficiency always a flaw?
Oh, I see.
Or is the loss function of being human actually tied to the things that don't scale mathematically?
Well,
The meandering conversations, the illogical hobbies, the emotional turbulence, really just the sheer unoptimized friction of human connection. If we perfectly optimize our lives to operate like a machine learning model, do we risk optimizing out the very qualities that make the experience worth having in the first place?
wow. If you strip all the friction out of the system, there's basically nothing left for the tires to grip.
Exactly.
We might win the race, but we've completely engineered the joy of driving right out of the vehicle. That is an incredibly fine line to walk between becoming effective and just becoming a machine.
It really is the ultimate balancing act of the modern age.
And definitely something to map out in your own personal state space. Thank you for joining us on this deep dive. Keep questioning the unseen architecture shaping our technology, and more importantly, keep questioning the alignment of the systems shaping your own life. We'll catch you next time.